Good morning, everyone, or good afternoon, depending on where you're joining us from, and welcome to today's webinar. I'm Cess, your host from Business Review, and it's truly a pleasure to have you all here. We're delighted to have our wonderful sponsor, Donaldson Filtration, with us today, who'll be presenting this webinar titled Best Practices for Sterilizing Alternative Protein, Fermenters, and Feedstock. Let me introduce our esteemed guest speakers for today. Our first speaker, Jacqueline. Jacqueline manages the Global Alternative Food and Protein Division at Donaldson Filtration Solutions. She has a degree in chemical engineering and a background in fermentation research and process engineering. She previously worked as a technical business specialist for plant-based food and beverages at Donaldson, and now continues to work with a global team of technical specialists to support the process and product integrity of alternative food and protein producers through the application of innovative filtration solutions. And our second speaker, Antonio. Antonio works as an application specialist at Solaris Biotech, part of Donaldson's Life Science Division. He has a master's degree in industrial biotechnology, and he previously worked as a research fellow for the Italian National Research Council, investigating microbial biotransformations to obtain natural fragrances. He is currently based in Cambridge, Massachusetts, where he provides technical support to the local sales and service office. Now, before we dive into the content, let me take a moment to familiarize you with our webinar platform On24. This webinar is browser-based, so if you happen to disconnect for any reason, simply click on the link provided in your email to rejoin the session. Also, today's webinar will be recorded and available on demand access. Should you have any questions or thoughts throughout the presentation, feel free to use the questions widget. Just type your questions into the box located at the top right-hand corner of your screen and click submit. We'll set aside time at the end of the session to address your queries. For any technical assistance, the yellow help widget is at your service, and you can adjust, resize, or maximize any of the windows on your screen for a better view of the slides. As we wait for more participants to join, we invite you to engage in our upcoming polls. Your participation is greatly appreciated. Our first poll. What sector are you involved in? Thank you, everyone. On to the next poll. What type of product do you produce? Some interesting results there. And on to our last poll. What stage of production is your operation currently in? Big thank you to everyone who participated. Now, without further ado, let's extend a warm welcome to our first guest speaker, Jacqueline.
Hi, everyone. Thank you so much for joining today, and thank you, Cess, for the wonderful introduction up front. As Shirley mentioned, my name is Jacqueline Simons. I'm the Global Sector Manager for Alternative Food and Protein at Donaldson Filtration Solutions. I'm here along with Antonio today, our application specialist from the Donaldson brand Solaris Biotech, and we're excited to be here together to talk about what can sometimes be a challenging topic for manufacturers in the ever-evolving new foods industry, and that is the best practices for sterilizing alternative protein fermenters and feedstock. While this is a very broad and complex topic, we'd like to break it down today to focus on some of the most common methods that you can apply to help prevent contaminations in your fermentation process. We'll briefly touch on the current regulatory landscape before we dive into the details of preventive controls and typical applications. And then later I'll transition over to Antonio so he can discuss some bioreactor basics and an overview of equipment sterilization. As already mentioned, if you have questions, please do submit them to the Q&A box, and we'll be very happy to leave time to answer your questions at the end. So before we jump into the technical stuff, I'd like to give you a short overview on who Donaldson is. Our purpose at Donaldson is advancing filtration for a cleaner world. We do this by providing filtration solutions to a vast range of industries, from agriculture and industrial manufacturing, powertrain and transportation, to biopharmaceutical, and of course, food and beverage. We have been providing food and beverage industries with high-quality filtration products for several decades. Our innovative solutions for the filtration of air, liquid, and steam help our customers maintain their process and product integrity. We serve several food and beverage submarkets across the globe, including alcoholic and non-alcoholic beverages, dairy, food ingredients, and of course, the alternative food and protein sector. Antonio and I are both part of the food and beverage division within Donaldson. Our department sits within the larger Donaldson Life Sciences portfolio, which is all about providing solutions to help address the evolving needs of growing global communities, whether that be through technologies that accelerate the development of therapeutics and biopharmaceutical spaces, or evolving the way that we create foods through cultivation technologies for alternative proteins and bio-derived materials. In the food and beverage team, we are focused on meeting the demands of process integrity in the industry and supporting the production of sustainable food alternatives. Donaldson has a long history of helping customers meet manufacturing regulations to produce safe and clean food for consumers. As a new and evolving industry, one of the main questions today is how the alternative food and protein space will be regulated. Around the world, the production, labeling, and the sale of alternative food and protein products varies greatly. Many of the laws and regulations currently being debated today surround the labeling of the products rather than the specific manufacturing requirements themselves. But with that said, all food producers should be following current good manufacturing practices, or CGMP, for human food. These practices are outlined as part of the Food and Drug Administration, or the FDA, in the United States, but it should be noted that the degree of specific requirements will be dependent on the local regulatory body. Along with that, I'll note quickly that in our presentation today, any reference to sterilization or sterile practices is in regards to the definition of sterile outlined by the FDA, but this definition may also vary depending on the regulatory body. While the exact regulations around the world may differ, no matter where you are located, preventive controls are an important part of any food manufacturing process. Here you can see two sections of CGMP, the Code of Federal Regulations of the Food Safety Modernization Act, both of which mention the identification of risk and implementation of preventive controls to address those potential risks. When it comes down to it, preventive controls are a key part of any food regulation. Aside from just regulations, though, there's many other reasons to implement preventive controls in your facility as well. By definition, preventive controls are strategies and equipment implemented to help address hazards in a food manufacturing environment. Hazards can present as microbiological contaminants, particulate, or other process and product safety hazards. The main goal of preventive controls is to stop these hazards from entering the food manufacturing process in the first place, but they also help prevent larger threats to your product and your company. Implementing these controls can also help prevent downtime due to equipment damage, process integrity, contaminations that might require you to shut down your process for clean-in-place procedures. They can help prevent economic loss and product loss due to lower yield, and they can also help prevent damage to your brand image. We all know that product recalls and food contaminations can greatly impact the consumer image of your brand. And in an industry where many brands are new and we're all trying to advance the industry for good, not having preventive controls in place can risk setting all of that back. So how do we apply preventive controls to the fermentation or the cultivation process? Although I'll be talking about fermentation throughout most of this presentation, the fermentation and cultivation process are different processes, but they require similar preventive controls, similar utilities. In an industrial food and fermentation process, there are many different points where hazards can be introduced. When I refer to hazards, there are two types that I'll be talking about. The first one is particulate, and the second one is microbiological contaminants. Particulate is any suspended solid, such as sand in municipal water or dust in your air source. Microbiological contaminants may be bacteria that grows in your feed solution or other unwanted microorganisms. Today, I'll focus on preventive controls to address hazards that may be introduced through utilities or anything that will enter the bioreactor or come in direct or indirect contact with the food product. To avoid contaminations, the fermentation feed solution, the air and gas, the steam, the liquid, and the equipment itself should all be sterilized to maintain an environment that can effectively support fermentation. As we discussed on the previous slide, not implementing controls outside of the bioreactor or fermenter can have effects on the efficiency of the biological process supported within the fermenter. The introduction of contaminants can result in a lower product yield, which means less final product and a lower return on investment for manufacturers. Knowing that preventive controls are an important part of any food manufacturing process, let's look at what methods are available to you as a manufacturer. As defined earlier, preventive controls are strategies implemented to help eliminate a hazard. In general, this could be a process control, a food allergen control, a sanitation control, or a supply chain control. There are many methods that can be used for each of these types of controls that may take the form of additional equipment, sensors, addition of heat or cold, addition of chemicals, a quality control point, or even a company policy or procedure. However, some of the most common preventive controls and simplest to scale are physical control methods, which often take the form of facility equipment and additional infrastructure. We'll focus on physical control methods that are widely available and used across the industry, from research and development all the way through commercial production. As you can see here, there are two main types of physical control methods: removal of a contaminant and destruction or inactivation of a contaminant. Within these categories, there are also many different ways to address the contaminants, but let's discuss two of the most common methods: filtration and heating. Filtration is a way of removing the contaminant, while heating is a way of destroying or inactivating the contaminant. Both of these methods are very commonly used in laboratories and in industrial manufacturing environments. The equipment used at a lab scale versus an industrial scale will usually differ, but the method and applications may remain the same. These methods tend to be easily accessible, reliable, and effective measures for helping address contaminants in the manufacturing of all types of foods, including alternative proteins. There are different types of equipment that can be used to implement each method. For filtration, we'll look at depth media filters, and for heating, we'll discuss autoclaves and direct steam injection. If we compare these methods, we'll start to see how the advantages and disadvantages compare, but what may be a disadvantage for one manufacturer may be an advantage to another, which is why the most important consideration for choosing a method is your specific product, process, and future production goals. We'll talk about what the best use cases are on the next slide. But aside from just what the method is, manufacturers also need to consider many other factors. For example, how much energy is required to run it? Is heat required? Can it be scaled from a lab setting to manufacturing level? How much does it cost initially? How much does it cost to maintain? The most important part of choosing a control method is understanding your own product and process. Are you working with proteins that can be denatured by heat? Are you in a location where the quality of municipal water fluctuates by season? Are you a startup that wants to scale, or are you a research facility focused on flexibility of resources? These are all questions that are commonly asked when considering the preventive controls used in a food manufacturing facility. While there are no right or wrong answers, it's most important to determine the priorities within your own facility and your own food process. So while it may seem that this is a case of trial and error, and sterilization of fermentation media is a fairly new concept, the reality is that we have plenty of similar applications to draw expertise from. For example, if we look at what fermentation feedstock is, it can range from pharmaceutical industry solutions to water with a little bit of sugar in it. In order to cut down on the price of traditional media and find the best fit for each specific process, many alternative protein companies are now making their fermentation feed solutions in-house, and they primarily contain a mix of water, sugar, and other nutrients. Sugar solutions are also common and require preventive controls in the soft drink and beverage industries. There we can find a long history of liquid sugar solutions and how to handle them. Production of stocks, sodas, wine, juice, and other beverages that often have a higher sugar content than the feedstock we use in our industry can all provide insight into the best practices for implementing preventive controls for modern fermentation feedstock. So if we use liquid fermentation feedstock as our case study here, let's look at the three main methods we just discussed and what their best use cases are in the alternative food and protein industry. Autoclaves use steam under pressure to eliminate microbiological contaminants. To sterilize fermentation feedstock or other liquids, they are prepped and placed in the pressure vessel, and steam is fed into the vessel to heat the product inside. The steam remains in the vessel at a desired temperature for the desired time, which is usually over 120 degrees Celsius and longer than 15 minutes. These devices are very commonly used on a lab scale, which is their value application. Autoclaves can only operate as a batch process, and they are one of the more expensive methods of sterilization due to the price of equipment and the price to maintain and run the equipment. Industrial scale autoclaves are even more expensive and energy intensive, so the best use case for this equipment is for low volume, small scale, or highly viscous solutions. They are, though, quite flexible solutions because the parameters do not change much based on what is placed into the autoclave. So they're all very well suited when flexible solutions are required, such as in research and development settings. Steam injection can also be done in different ways. I'll break it down between this slide and the next one to talk about a batch process steam application and a continuous process steam application. In the batch process, this method is favored because it requires very little additional equipment. For a typical application, the feedstock is loaded into the fermenter directly, and then the steam is injected into the fermenter to sterilize the feedstock, any other material, the feed lines, the bioreactor, and the piping equipment to the bioreactor. This process requires that you have quality steam and a direct steam source, but not much other equipment. This can be done on the lab scale or industrial scale, but as a batch process, it does require time that does not cater to large continuous operation manufacturing. Additionally, the steam that is injected into the fermenter cools and remains in the fermenter and dilutes the feedstock, which is not necessarily an advantage or a disadvantage, but it does need to be taken into consideration. This type of sterilization is great if you're doing research and development and might be using different feedstocks or different conditions. Direct steam injection does not rely heavily on the process or product, so it can be used for a wide variety of applications. If a continuous feed is required, continuous steam injection can be done at an industrial scale with a high volume of feedstock or liquid. In this application, the liquid fermentation feedstock is fed into a piping loop where steam is continuously fed into the piping. This application uses higher temperature steam and shorter steam time compared to the batch process or autoclave, and there is a rapid expansion step at the end that facilitates flash cooling. This makes the continuous process much faster compared to the batch steam injection, and fermentation feedstock can then be fed directly to the fermenter. Due to the fact that it requires specific equipment and infrastructure, the continuous direct steam process is only suited for industrial scale production. Filtration is the only method we'll talk about here today that uses removal of contaminants over inactivation or destruction. This method also does not require heat, so it is well suited for any application that may use heat-sensitive products. Best practices for liquid filtration includes 3 steps. The first one is applying a nominal particulate filter. This filter removes large particles and helps protect downstream filters and equipment. Overall, this step reduces particle load and the number of suspended solids in the process. The second step is applying an absolute particulate filter. This removes all particles greater than the filter micron size based on the filter retention rating. The third step of the process is applying a membrane filter. This is the part where the filter addresses microbiological contaminations as defined by the retention rating of the filter. Membrane filters should always be integrity tested and sterilized regularly. While filtration can be used at the lab scale in the form of filter syringes or capsule filters, the method discussed here uses industrial scale equipment and is not usually applicable at smaller scales. After filtration, the feedstock can be fed directly to the fermenter for production, making it well suited for continuous industrial scale processes, feedstocks that have particulate present, and high volume applications. For anyone fitting this scenario, Donaldson offers an extensive portfolio of liquid filtration solutions with some of the main products shown here on the screen. These products are designed to help protect your product and your process integrity in fermentation, production, and beyond. Not only does Donaldson offer liquid filtration solutions, but our portfolio covers air, gas, and steam as well. Our products can be implemented upstream and downstream of a fermenter in product utilities, at point of use, and anywhere else that you may have critical control points needed in your process. Donaldson aims to support our customers around the world with a team of technical experts, superior customer service, a value-driven team, and operational excellence. We'd be happy to assist you in meeting your food manufacturing needs. We work closely with our partner brand, Solaris Biotechnology, to provide an end-to-end fermentation solution. And with that, I will go ahead and pass it off to Antonio to talk a little bit about Solaris Biotech's offerings and the process for sterilizing a fermenter.
Thank you so much, Jacqueline, and thank you everybody for joining. Well, who am I? You can see some of my bio in there. And talking about Solaris Biotech was founded in 2002, and it is an Italian company specializing in fermenters, bioreactors, and filtration systems for R&D and production purposes. Solaris became part of the Donaldson's Life Science division in November 2021. So let's deep dive and let's start giving a little background on the regulatory aspects. Alternative protein manufacturing, as Jacqueline was mentioning, is subjected to the Food and Drug Administration regulations, as they are considered as food for human consumption. I quoted here the Code of Federal Regulations, so CFR, that highlights the guidelines commonly referred to as good manufacturing practices, which help bring safe and controlled food to consumers. It is clear at a first glance that not only the material is important, but also its design, the construction, also in terms of seams and processing of the material itself. It is also mentioning that the equipment shall be adequately cleanable and sterilized and sanitizable to minimize the opportunity for growth of microorganisms. Today, we're going to focus on this aspect along with the sterilization and why they're fundamental to prevent both food contamination and financial loss. On this matter, Solaris can offer CGMP compliant packages to certify the adherence to the GMP request. So let's take one step back for those of you who are not familiar with bioreactors and fermenters. So what is a bioreactor? It is basically an equipment used to create a tightly controlled environment and optimal conditions to sustain cell growth. It usually consists of a vessel or a tank that contains a liquid medium in which the cells will find all the nutrients required to duplicate. But what happens inside a bioreactor? The main goal is to grow cells, which could be any kind of cells. It can be bacteria, fungi, mammalian cells, plant cells, insect, microalgae, and so on. Different cell lines will require slightly different configurations in order to be able to optimally sustain their growth in terms of oxygen, nutrient, and environmental requirements. We already know that from cells we can obtain the most amazing things. We could start mentioning the simplest things like wine and cheese and end up mentioning antibiotics or vaccines or whatever other thing comes to our mind. Sometimes we are interested in obtaining something that the cell is producing, like in precision fermentation, for example, in which we are obtaining proteins, fats, and other valuable molecules that will be used to formulate food. Other times we're aiming at obtaining the whole cell, right, like the biomass. Let's think about the cultivated meat or the plant-based food made out from fungi. So why do we need to sterilize a bioreactor? Prior to getting to the bioreactor stage, there are a lot of steps. A specific cell line or maybe a pool have been selected since it was offering the best yield in terms of biomass or metabolite production. We must be sure we're cultivating the right cells and nothing different, nothing else, because we need that specific strain. A contaminant could act as a competitor for the nutrients of our selected strain and impair its growth. It could also develop metabolites which could potentially be toxic for the cells themselves and or for the final consumer. The yield of the process would clearly be impaired. Sterilization of the bioreactor and its surrounding lines ensures we can have a high reproducibility of the process, since it is possible to have a clear control on my cells that I'm growing and on the cultivation parameters. We can avoid both the formation of flavor-altering or potentially toxic compounds, or the growth of potential human pathogens, granting a high-quality and safe final product that meets the regulatory guidelines. It helps preventing losing batches, which at R&D scales could just mean losing an experiment and have to reprogram that and start from scratch. But at manufacturing scales, of course, with thousands of liters, it could mean losing a lot of money. So how can we sterilize a bioreactor? The most used destructive method for the sterilization of the bioreactor and its components is heat. Thermal sterilization through steam, being used directly or indirectly, will bring temperature to a desired set point for a certain time. The heat will cause cell membrane damage, DNA damage, and protein denaturation, compromising the microorganism functions and potentially leading it to cellular death. In general, we could start with the evaluation of the bioburden, which is an index of how many microorganisms I have prior to sterilization. Every microorganism has its own resistance to thermal treatment, and it must be taken into account that endospores have typically higher resistance compared to cells which are in their vegetative state. In general, the objective is to reach the safety assurance level, SAL, which means having a 6 decimal reduction in the number of the microbial population. Management of time and temperature is often used to reach sterilization, but in case we have thermally labeled compounds in the medium, we could consider sterilizing based on F0. F0 is the equivalent time to reach the SAL when considering a different temperature than the standard 121 degrees Celsius. So what do we need to sterilize? Of course, the cultivation medium, which is the liquid containing all the nutrients such as glucose, proteins, vitamins, other micronutrients, and so on. Typically, medium for microbial processes are crafted starting from powders or raw materials. For example, let's think about molasses or other byproducts that are being upcycled. And therefore, these media aren't sterile, and therefore they must be sterilized. Generally speaking, the components of microbial cultivation media are able to withstand a sterilization cycle, and so they can undergo a media sterilization cycle, which will use heat transfer through the jacket. Media for cell culture usually contain thermally labeled compounds which can't withstand high temperatures. It is possible to independently sterilize the empty bioreactor and then add in the media through filtration, or as an alternative, sterilize the medium and add in the thermally labeled fractions afterwards. During the process, it is often required to add solutions. As we know, feeding solutions will help reach optimal biomass growth, avoiding high concentration of the main carbon source right from the beginning of the process. Acid and base are used to control the pH level. Anti-foam will help, of course, controlling the foam formation. Inducers are fundamental to trigger changes in the morphology or to start the production of a metabolite. In general, it must be everything on the process side must be sterilized. The vessel, the piping, the transfer lines, but also scaffolds or microcarriers if we think about adherent cultured cell lines. During normal operations, all these components will inevitably come in contact with the air and possible contaminants, so they must undergo sterilization cycles as well. So Solaris covers the whole range of products from benchtop bioreactors through pilot and up to manufacturing scale, according to the volumes and to the characteristics of the systems that we can have autoclavable and sterilizable in place equipment, so SIP equipment. The autoclavable solutions won't require a steam generator, and there will be no need for steam lines in the lab. On the other hand, the bioreactor will have to be handled and brought to the autoclave. This, together with the autoclave size, starts becoming a hurdle when considering autoclavable solutions with high volumes and a high number of vessels, which will generate a long turnaround time. In addition, no sterilization can be done during the process on any peripheral line, which are usually silicone tubes managed through peristaltic pumps. Solaris equipment has been designed to grant optimal handling and fast setup prior to autoclaving. Getting higher with the volumes, autoclaving is not an option anymore. Sterilizable in-place solutions require steam availability, but gives the chance to sterilize the bioreactor and its components in loco. The peripheral lines can be sterilized during the process to lower the chances of contamination due to additions, sampling, and transferring from or to other plant equipment. Along with the main bioreactor, all the feeding tanks, harvest tanks, and other ancillary equipment must be autoclavable or sterilizable in place, which is something that also Solaris can offer. A couple of slides ago, we mentioned different methods for sterilizing an SIP bioreactor. During the media sterilization, the steam will flow through a heat exchanger and heat up water in a closed-loop recirculation jacket. The heat will be transferred to the vessel and will reach the desired temperature. This is used, of course, to sterilize the cultivation medium prior to the inoculum, but could be also really helpful when working with BSL-2 microorganism or higher. In fact, we can just inactivate the microorganism in the bioreactor prior to harvesting. During the empty sterilization, clean steam will be directly injected in the vessel. As I mentioned before, it can really come in handy when you have thermally labeled compounds. And in this case, the empty vessel gets sterilized, and then the medium will be added afterwards through filtration. Also, the vessel can be sterilized after the harvest phase to inactivate the remaining microorganisms. Again, in case of a BSL2 or plus or something which is potentially dangerous. The Solaris system offers flexible recipe configuration. This is true, of course, also for the sterilization phases. It is possible to operate based on time and temperature or the equivalent time, so F0. The software grants control over the main sterilization variables and on the PID parameters. It is possible to automatically monitor both the vessel and the peripheral lines sterilization through counters associated with temperature probes. So what about the cleaning? Why do we need to clean a bioreactor? Well, sterilization takes care of the living microorganisms, inactivating them. If the vessels and all its components aren't properly cleaned, a biofilm could potentially form. A biofilm is an aggregation of microorganisms that accumulates on a surface. The biofilm is the optimal field for the microorganisms to sporulate. Spores are, as I mentioned earlier, much more resistant than cells themselves, and so they can withstand higher temperature and longer sterilization times. This, of course, will bring back the problem to the sterilization, so we'll have to find the right way to do that. It's not just about the cleaning, it's not just the alive contaminants that could compromise the entire process. Different processes with different strains and products are run in the same bioreactor. So a good cleaning process will avoid cross-contamination and potential carry-ons that will impair the purity and possibly, of course, the safety of the final desired product. Again, it is really important to follow the CFR guidelines. And Solaris can offer a package with material certificates, which are along with the roughness certificates, welding books, to be sure that your equipment is meeting the standards. So how it is possible to clean a bioreactor? For smaller scale vessels, it is possible to clean the equipment by hand, of course, opening the head and accessing all the components in contact with the process. This is acceptable and easy to manage for benchtop units, as they are generally light and all the parts are easily reachable. Regarding hourglass and stainless steel solutions, they have been designed to grant fast disassembling. Of course, when it comes to pilot or manufacturing scale, the hand cleaning process becomes a hurdle, physically speaking, and a limiting factor to a fast turnaround time. Spray balls will be introduced in dedicated ports on the vessel and clean the internal part of the vessel through the recirculation of a pressurized cleaning solution. Positioning of the spray balls is fundamental to avoid creating shadow areas due to the presence of bioreactor components such as shaft, impellers, sensors, and so on. We offer two different solutions for cleaning in-place systems. They can come with an integrated CIP solution, which will use the vessel as the preparation tank for the cleaning solution. Or the bioreactor can be configured to work together with an external CIP. An external CIP will provide the operator with a separate tank for the preparation of the cleaning solution. The solution can be preheated to the selected temperature, and cleaning of the peripheral lines can be run while the process itself is running. Whatever the setup is, integrated or external, rinse and recirculation times can be selected and customized for every single spray ball. The cleaning solution can be mixed and brought to the desired temperature, and recirculation will be activated. What happens is that rinse and wash phases will alternate until the desired clean grade is reached. Conductivity probes are often used to monitor the cleaning process, offering a way to monitor the ion concentration in the cleaning solution on the return line from the vessel. The peripheral lines, transfer lines, gas out, gas in, and so on can also be included. And usually what is done is to take into account TACT, so time, action, concentration, and temperature to reach a reproducible cleaning cycle. And with this, that's all. Thank you for the attention. And if you have any questions, we'll be happy to take them.
Great. Thank you, Jacqueline and Antonio, for your informative presentations. Now let's dive into our Q&A session. A quick reminder for our audience: to ask questions, simply use the questions widget. Just type your questions into the box at the top right-hand corner of your screen and click submit. So let's kick things off with this first question. It was mentioned that Donaldson supplies depth filters for liquid fermentation feedstock. Do they have any other types of filtration solutions?
Yeah, absolutely. So Donaldson, in our food and beverage process filtration group, a majority of our products are depth filter cartridges, but we also offer cross-flow filtration solutions, condensate management systems, dryers, filter test equipment, and other system engineered solutions. So a majority of what was discussed today was the depth filter elements, but we do have other ones in our portfolio, absolutely.
Great. Thank you very much, Jacqueline. Another question that we've gotten from the audience is, what is the quality of steam you use for sterilization? Food grade with reverse osmosis, water, or filtered water with a point filter?
Sure. Okay. Yeah. So I'll take this one again. Yeah, for the quality of steam, it's always nice to start with filtered water already. But as mentioned, we also recommend point of use filtration for steam. So for the quality of steam, definitely culinary steam would be recommended. So that's approved for direct contact with food products and food processing equipment. So for quality of steam, you definitely want to go for culinary grade steam, and for the water before it, really as clean as you can get it is nice, because then it's easier to achieve that level of steam for the culinary grade steam. So that is again regulated under the local regulatory body. So here it would be the FDA, and so they'll outline kind of the exact specifications that you need to achieve that quality of steam. But definitely culinary steam would be the best option.
Great. Another interesting question that we've received is, we're currently working with benchtop units for our alternative protein process. Does Solaris offer fermentation and bioreactor technology that can be used for larger operations?
Yeah, sure. I'll take this, Jacqueline. Sure. Solaris portfolio ranges from the benchtop units up to the manufacturing scale, up to 30,000 liter. So yes, of course, we can support you on the scale up and so on. Thank you for the question.
Fantastic. Moving on, what are some of the most common feedstock types you see used in the alternative protein industry?
Sure, I can take that question. For me, though, a lot of the customers that I work with, as I mentioned during the presentation, have shifted to making feedstock solutions in-house. So usually they're utilizing a water-based solution that contains sugars and other nutrients. It can range, though. Some will use For cultivation, even some will use fetal bovine serum or pharmaceutical grade feedstocks. But for food manufacturing, what I most commonly see with producers would be that basic sugar solution. So as mentioned, those are very similar to what's been used in the food and beverage industry in other areas, such as sodas and other soft drinks. So it does make it a bit easier for manufacturers to kind of understand the regulations and what can be applied to those solutions if they kind of mimic that in their process as well. So I'd say a majority of the customers that I have worked with will be using a sugar-based feedstock solution.
Great. Thank you, Jacqueline. And continuing on with that topic, we've got this question from an audience member. Do preventative controls such as filtration only apply to fermentation, or can they be used for plant-based food as well?
Yeah, I'll take that one again. They definitely can be applied to fermentation as well as plant-based foods. So a majority of the products we're applying to utilities, the water, the steam, the air and gas. So that is part of most any food manufacturing facility, whether it's alternative proteins, plant-based foods, other, dairy, other foods in the industry outside of the ones that we focused on today. And so they can definitely be applied to those other products as well. You're really applying the preventive control to the utility rather than the end product itself. So any of that stuff that's going into making the product does tend to be similar across the food manufacturing industry. You can definitely use these solutions in all of those areas.
Perfect. And I'll ask this last question. Could we use hypochlorous acid without rinsing as it disappears after a certain time?
Yeah, sure. I'll take this. So usually we always suggest to proceed with the rinse cycle. Even the compounds we're using for the acid rinse and acid wash phase are a label and they will just evaporate or anything. So yeah, you could do that if it's not impacting your culture and you don't see any let's say negative effect on your culture, or maybe on the components of your medium if they produce any undesired effect.
Great, thank you so much, Antonio. And we've just got a question slip in, so I'll ask this final question before we close our Q&A session. How would you approach media sterilization for large-scale media preparation at lowest cost? Would the cost of raw materials, e.g. filter elements and turnaround time for changeover, be prohibitive to filtration?
Yeah, I'll take that question. Very good question. The two discussed in the presentation today that work at very large scale manufacturing for those high volume applications would be continuous direct steam injection as well as filtration. And so definitely not prohibitive to filtration at that high of a volume. If you have the correct filtration solution, depending on micron size and the three-step process that we highlighted today, if you effectively are using the correct setup for your process, for your volume flow, for your specific media, it is a very great solution, and the filters will last quite a while and be able to filter a high volume of that media for you. So for large scale, it's definitely a better application for these filtration solutions than at a smaller scale, I would say.
Great. Well, excellent responses, Jacqueline and Antonio. As we're nearing our end of the scheduled time, we'll have to conclude our Q&A session. But please don't worry if your questions haven't been answered yet, as the speakers will follow up with you. And that brings us to the end of the session and webinar. I'd like to express my heartfelt thanks to Jacqueline and Antonio for their outstanding presentations, and to our sponsor, Donaldson Filtration, for making this session possible. To all of our attendees, keep an eye out for your email on instructions on accessing the on-demand version of this webinar, and you can also find it on our website at www.pmi-live.com. Stay connected with us for more exciting webinars, and follow us on Twitter at BR Webinars for daily updates, and join our LinkedIn group Business Review webinars. Once again, thank you for joining us today, and I wish you all a wonderful day ahead.